In order to calculate from moles of one substance to moles of another, we need the balanced equation, and the balanced equation is right here. So the question that is being asked is how many moles of sulfuric acid are needed to make 4 moles of HCl? So we start with our given, which is 4 moles of HCl. So we have 4 moles of this, and we want to find out how many moles of sulfuric acid we need in order to make those 4 moles. So, as with anything, we start with our given, which would be 4 moles of HCl. Okay. Our next step is we know that we need to cancel out moles of HCl. And to go from moles of HCl to moles of H2SO4, we need our mole ratio. And our mole ratio comes from the balanced equation. We get this from the coefficients of our balanced equation. So we have 6 moles of HCl, which will go on the bottom. So we plug that 6 in there, and the 3 moles right here. After we have done that, we cancel our moles of HCl. We're left with moles of H2SO4, which is what we want. So we are done. We already have our units that we want. Now we just have to do the math. So we take 4 times 3, we get 12 divided by 6, which would give us 2 moles of H2SO4 are needed in order to make 4 moles of HCl. We started with our given, which was 4 moles, and then we used our mole ratio to go from moles of HCl to moles of H2SO4. A mass-to-mass calculation is a little bit more complicated, it's a little more involved, there are a few more steps, but we start in the same way. So the question is saying how many grams of aluminum chloride, so we're looking for grams of aluminum chloride, are needed to produce 30 grams of HCl. So we have 30 grams over here. So we're going from grams to grams. 30 grams is our given, and we're going to grams of AlCl3. We start the same way that we always start with our given. So we have 30 grams of HCl. We know that our first step is going to be to get rid of our grams, and in order to get rid of grams, we need to use the molar mass. So the molar mass of HCl would be 36.46 grams, and 1 mole on the top. Once we have gone there, we're now in moles of HCl because our grams have canceled. So our next step is now the mole ratio. So we have moles of HCl on the bottom. We're going to moles of aluminum chloride. So we look at our balanced equation and we see that our coefficient for moles of HCl is 6. Our mole ratio for AlCl3 is going to be 2, so we place that there. After we cancel out our moles of HCl, we're now in moles of AlCl3, but we don't want moles, we want grams. So we have one more step that we need to do, and that's using our molar mass of AlCl3. So in order to cancel out moles, we have to have moles of AlCl3 on the bottom. That's 1, and there are 133.33 grams in 1 mole of AlCl3. Our moles are left. We're left with grams. Fortunately, that's what we want. They match. Okay, so we're left with grams of aluminum chloride. And then we would do the math in order to calculate this out. Once we do the calculation of multiplying across the top, multiplying across the bottom, and then dividing, we end up getting 36.57 grams of AlCl3. We started just like we did before. We started with our given. After our given, we used the molar mass of our known substance, or of our given. Then we have our mole ratio. And finally, we have our molar mass of our unknown. Sometimes we want to do a particles to particles calculation. We're still using the same balanced equation. So in this question, we are going from molecules to molecules. So how many molecules of aluminum chloride are needed to produce 1,000 molecules of HCl? So we start with our given, which our given would be here, 1,000 molecules. And we're looking for how many molecules of AlCl3. So this would be our what we want. We start the same way as we start everything with our given. So we have 1,000 molecules of HCl. Our first step is to go from molecules to moles, because moles is the only way we can cross over from one substance to another. So we use Avogadro's number, which is equal to 1 mole. Our next step is then our mole ratio. Our mole ratio comes from, again, the balanced equation. So we have moles of HCl, and we're going 2 moles of AlCl3. 6 is from the ratio portion of the HCl. AlCl3 is going to be 2. We plug those numbers in there. Our next step, these have canceled. These have canceled. This is canceled. This is canceled. So we're at moles of AlCl3, but we have one more. We want to go to molecules. So we again have to use Avogadro's number. So we have 1 mole of AlCl3, and Avogadro's number is equal to that many molecules. So that is the setup. These will cancel. We're left with molecules. That's what we want. They match, and then we do the math. When we finish the calculation, we find that 1,000 molecules of HCl can be produced from 333.33 molecules of AlCl3. We started this problem as we did with every other one with our given. Then we used Avogadro's number. Then we used our mole ratio to go from one substance to the next. And then we used Avogadro's number again to get back to particles. The last example I'm going to do is if we mix up a couple of those different types of calculations and if we need to go from mass to particles. So we look again at our balanced equation and we look at the question, how many formula units of aluminum chloride are needed to make 100 grams of HCl? So our given is obviously 100 grams of HCl. Grams is a mass. And we're going to formula units of aluminum chloride, so we want to know how many formula units are needed. We start, as we start everything else, with our given, 100 grams of HCl. In order to go from grams to moles, again, so that we can get to that mole ratio, because that's how we cross from one substance to another, we need the molar mass. The molar mass of HCl is 36.46 grams of HCl. That's how much is in 1 mole. Our next step is then the mole ratio. So we have moles of HCl over moles of what we're going to, which is AlCl3. We get these numbers again from the balanced equation. So 6 goes with HCl, 2 goes with AlCl3. After that, we have canceled out our grams, canceled moles of HCl. We're left with moles of AlCl3. So we're not done because we want formula units. Our next step is there are Avogadro's number of formula units in 1 mole. So we use Avogadro's number, formula units in 1 mole, and then we do our calculation. Our answer will end up coming out to 5.5 times 10 to the 23rd formula units of AlCl3. You'll notice that our moles had canceled and we were left with formula units, which is what we wanted. We started again with our given. From our given, we used the molar mass of our known to go from the mass to the moles. Then once we knew the moles of our known, we could use the mole ratio to figure out how much of our unknown we'd need. And then because we were going to particles, we had to use Avogadro's number of particles. Formula units is a particle.